Java has several different types of loop available for repeating actions in a program. For a beginner, it can be difficult to know which type of loop to use in any particular situation, and the wrong choice can lead to awkward coding. Beginners tend to stick with the first type of loop they learned about because they have the most experience with it, but it won't always be the best choice. In this video, we will provide some examples of Java's while loop because it is the most versatile type of loop and can be used in every situation that requires a loop. While a more specialized loop might be more appropriate in certain situations, you won't ever find that a while loop cannot be used, which is not the case with other types of loop. So spending some time becoming proficient with a while loop will definitely pay off in the long run. We will start with some simple examples to illustrate the basic features of the while loop, and then go on to develop a number guessing game that will allow us to explore variations of the basic structure. We will be using the BlueJ IDE in all of the examples, but the concepts can be used with any IDE. Code involving a while loop typically has four parts to it: something that happens before the loop's header including a Boolean condition, something that happens inside the loop, and something that happens after the loop. This code illustrates all four of those parts. Because the loop's operation is controlled by a Boolean condition, it is often convenient to define a local Boolean variable for this purpose, which is what we have done here. Before watching further, you might like to pause the video and consider the following questions. Firstly, what will the output from this method be? Secondly, suppose the loop variable had been initialized to false rather than true. What would be the output in that case? Take a moment to think about that to test your understanding of how while loops work. If you ever wonder what a program would do in a particular situation, the simplest way to find out is to try it. So let's do that with our two questions, but we will take the second question first and change the loop variable's initial value to false. I can create an instance of the example class on BlueJ's object bench and then call its doSomething method. The output appears in the terminal window, and we can see that nothing was printed from inside the loop. That is because the variable setting of false prevented control from entering the loop. That's not particularly useful in this case, but knowing that could happen is worth storing away because it can be useful in those situations when you are not actually sure that you want something to be repeated. For instance, if you had an empty list and there is nothing to be done with any items in it. A loop to process the items would not be needed in that case. Now let's put the variable's initial value back to true and see what happens this time. Notice that BlueJ's work indicator shows that the program is running endlessly, so I will stop it manually, confident that it will never stop by itself. What we have written is called an infinite loop. Hopefully you can see why the program goes on and on printing the same output. It's because the Boolean variable controlling the loop never gets set to false inside the loop. We could add a statement to set it to false and run the method again. This time the statement in the loop's body is printed out just once. Can you see why? The problem with this is that there is not much point writing a loop whose body will only ever execute once. That's precisely what an if statement is for. With this simple example, we've seen how to skip over the body of the loop completely, or execute it exactly once, or repeat it forever. What we really want is to see how to code it so that the body is repeated exactly the number of times required by the problem we are trying to solve. So let's look at ways to do that. As well as using a Boolean variable with a while loop, it is common to keep track of how many times a loop has been repeated by using a counter initialized to 0 before the loop and incremented by 1 each time around the loop. Here is a variation of our infinite loop version. An obvious way to stop the loop would be to look at the value of the counter variable, and if it has reached a certain limit, change the loop variable's value to false. We can do that with an if statement inside the loop. Now when we run this method, it stops after the coded number of repetitions. Notice that the if statement does not need an else part. That would simply set the loop variable to the same value it already has, which would be pointless. But it is a common error that beginners make when writing the if statement inside the loop to check whether it is time to finish or not. Before we move on to another example, you might like to take a look at this alternative version of the loop that does not make use of a Boolean variable to control the loop. Does it print exactly the same output? Why not try it for yourself and see? We are now going to use the features we've been looking at to develop a simple number guessing game. The idea is that the program will generate a secret random number and invite the user to guess it. To give the user a reasonable chance, we will restrict the number to an integer in the range 1 to some upper limit. We will need a couple of library classes from the java.util package to help us: the random class for generating the number to be guessed, and the scanner class to make it easy to read the user's guesses. Here is the starting point of the guessing game class to set up instances of those two library classes. Here is the starting point for coding the heart of the game in the play method. Although there are a few more statements than in the previous examples, you should be able to recognize the overall structure as being very similar. We have a Boolean variable for loop control. This time it's called still guessing rather than keep going, but the way it will be used is the same. We have a loop condition that uses the value of the variable to decide whether to ask the user for another guess or not. We have a loop body that asks for a guess. Hopefully you can see that this version would result in an infinite loop, because there is nothing inside the loop body to change the loop variable's value from true to false, and we definitely need something to do that. Of course, we know from our previous exploration that we cannot simply write an assignment to the variable like this, because that would only allow the user a single guess. What we need, of course, is an if statement inside the loop that checks to see whether the user's guess is correct and changes the loop variable only if it is, like this. Let's give this version of the game a go. In the examples, we will use a small limit to ensure that the number is guessable within a reasonable time. That works fine. Although the output could be improved, it would make it a nicer game if we included features like congratulating the user on guessing the number and telling them how many attempts they made. When we looked at the previous program, we saw that we could get rid of the Boolean variable controlling a loop by using the counters value instead. Can we do the same with the guessing game? A first attempt might be as follows. But this version doesn't compile. Can you see what the problem is? The problem is that we want to use the user's most recent guess in the loop's condition, but the guess variable is defined inside the loop's body and is not accessible outside it. This is a scope issue, and if you are not quite clear about the problem, it would be worth reading up about the scope of variables in Java. On the face of it, the solution looks to be quite simple. Move the variable from inside the loop to outside the loop. But if we do that without thinking about it, things could go horribly wrong and end up being very difficult to get right again. Let's try this version and see what happens. We have ended up in an infinite loop again. Looking at the code, we can see that we have removed the code for reading a guess from inside the loop, so once we get inside the loop, there is no way of getting out again, because the value of the guess variable can never be changed. At this point, we might be tempted to copy the code back inside, so that we are now reading both before the loop and inside it. The problem now is that we have two definitions of the same variable in the method, and that is not allowed. While we can fix it relatively easily like this, The whole process has actually introduced a subtle bug into the code that will only be manifested when it is run. Can you see what it is? Remember, it is quite a subtle bug, but the sort of thing that is very common when coding. Here is a hint. It is called an off by one error. The problem is that the number of reported guesses is one fewer than it should be. Can you see how that has come about? The number of guesses variable is initialized to 0, and then the first guess is read, all before the loop's condition is tested for the first time. If the user guesses right first time, then we would have the situation where the loop's condition is immediately false and the loop's body won't be executed at all. We will skip immediately to the end of the method and print that the number of guesses was 0. The fix is relatively easy. Initialize number of guesses to 1 instead of 0. However, this process of moving from the version where the loop was controlled by a simple Boolean variable has proved to be a bit of a minefield, and also resulted in having to duplicate code from inside the loop, so the original version is probably to be preferred. Let's go back to it to make one final extension to the game. Let's limit the number of guesses the user can make to be around half of the number of possible values. If they don't get it within that number of attempts, then we will tell them the answer. What this new element adds to the loop control is that there are two possible ways of stopping the loop. Either the user has correctly guessed the number, or they have run out of guesses. However, we need to be careful here. We have just expressed the ways in which the loop can stop. Either the user has correctly guessed the number, or they have run out of guesses. It is important to remember that a while loop's condition must always be expressed as the conditions under which the loop can continue. So, we really need to say that the user can continue guessing as long as they have not yet guessed correctly and they still have more attempts. In Java, that means we need to use the Boolean AND operator to capture both conditional elements in the overall condition of the while loop, like this. There is one more thing that has to be done once the loop finishes. We cannot simply congratulate the user on guessing correctly, because in this version they might not have done so. However, there is another subtle bug waiting to bite us if we are not careful. Can you work out what is wrong with this? We know that there are two possible ways of finishing the loop, but both might have been triggered at the same time. In other words, the user might have guessed correctly on their final allowed attempt. So it is unreliable to check the number of guesses as a test for failure. While that will give the right result most of the time, occasionally it will not. The only reliable test is whether the still guessing variable is still true. If it is, then we can be sure that the user didn't guess correctly. But if it is false, we can be sure that they did. So this is the way to write the final if statement. In this video, we've looked at the core elements that go into writing a while loop. We must pay particular attention to the way the condition is written and ensure that something inside the loop will eventually make the condition become false. It is very easy to make off by one and other logical errors when working with loops, so thorough and careful checking is an important part of the programming process.